Hello, everybody. I'm Tim O'Rourke, Weight Trim's Chief Technical Officer, and I want to welcome you to Innovation Alley, a Weight Trim podcast. This is our second podcast, and we have a really cool topic today called reality capture, and we'll be covering a lot of innovative topics within that category. I'd like to introduce my co-host, Dave. Do you have your microphone right?
I finally do. I know this is a show about innovation, but the first thing is to make sure your mic is correct.
And yours is larger than everybody else's.
It is.
So, we just hope he's audible today. So, all right.
Hello.
So why don't you introduce our guest, Dave, and your kind of spin on reality capture.
Yeah. And I'm excited to be here co-hosting today. Our last episode, we talked a lot about the future of advanced data collection and remote sensing, and we're really excited to have a couple of special guests here that are experts in that. We have Jason Yoscovits and Brian Gombos. Jason, why don't you tell us a little bit about yourself?
Sure. I am a reality capture specialist with Weight Trim. I work in construction mostly and work well with the BIM leads in the Advanced Technology Group, Advanced Design Technology Group. I'm the guy that captures all the data.
You get the data, yeah.
I'm the capturer of the data.
In the field. And Brian?
Good morning. Thanks for having me, gentlemen. Again, my name is Brian Gombos. I lead our Advanced Design Technology Initiative, which has a number of different goals, but one of which is to pursue continuous improvement for our clients and our folks internally through the use of advancing technology. So this covers a lot of topics. Reality capture happens to be one that's really foundational to taking those next steps as we move towards a digital world.
And we are vastly moving towards a digital world right now. I'm going to tell a little story. I turned 60 this week.
Happy birthday.
Happy birthday.
Yeah. By the way, there's 2 Spartans to overcome this Wolverine. I don't know what your affiliation is, Jason.
Go green.
Okay,
Wow.
cool. Well, you're outnumbered today. And it made me kind of reflect back on my entire career, and I was thinking through, when I was in school, actually, at Michigan State, my dad's a surveyor, and I got my way through school by surveying in the summers, and one of the summer, between my junior and senior year, I was a survey party chief for Selfridge Air National Guard, kind of redo the apron. It was a huge job, and we literally shot, the grid of the future grades and the existing grades by taking, it took months to do the survey.
For like the runways?
Yeah, the runways, yeah. And I'm thinking today how inefficient all that was then with the technology we have today, right? So from reality capture perspective, when you guys started to pitch it to me, I hadn't even heard the term, but it's basically getting a digital result with using advanced tools that cuts time astronomically and feeding into what will be later a model-based design.
It gets a lot more data, right? Collects a lot more information.
No question.
Yeah.
No question.
Yeah,
You're providing millions, tens of millions, if not hundreds of millions of points on a project that would be the size. You could go billions. We can go billions.
Right.
On a project that size for.
You know how long it would have taken me with my survey linker rod? I mean,
And your chains.
and that's just in my career, right?
Sure.
I don't even want to say we didn't have laptops or we're using Fortran punch cards or anything.
Yeah.
Brian's a little after me at Michigan State. I'm sure you guys are using laptops. But this has been so cool to watch the evolution of this over time, and it seems to be accelerating. What you brought to us with BIM, 10 years ago, is accelerated to a point where it's you got to move fast to keep up with the Joneses, right?
That's a fact.
So I guess I'd start with you, Jason. You're the one that kind of brought to us kind of the frustration I just said, how long it takes to capture all this data with the old surveying capabilities, and then kind of assessing, how to move forward with that digitally.
Sure.
So why don't you tell us a little bit about why you dove into this, why this was your passion, and
Yeah, it's kind of a funny story. So I used to be the guy that when I was a construction inspector full time, which dates back quite a ways, but I would be up on man lifts and scissor lifts, crane baskets, taking pictures of the job sites, and not supposed to do that, right?
Are you a good photographer?
Yeah, I am.
Oh, okay.
So I would be up in these baskets taking pictures, and I thought, there's got to be an easier way to do this. But I had already been flying drones for a little while, small personal drones. So I thought, let's start utilizing drones as a tool in the field, right? And so I met, I talked with Andy, met with Andy and Ralph and guys within Wade Trim and talked about bringing these in as tools, and we did. And then I met Neil Wakeman, and Neil's the one that said, hey, we can do a lot more than what we're doing now with drones, and the rest is history. We're from aerial survey to LiDAR, aerial LiDAR scanning. We use, it's a general part of every project.
Well, it is, but that isn't that easy. When you say Andy, we're talking Andy McCune, our CEO.
Yes,
we're talking
correct.
Ralph Bacano, our chief financial
How
officer.
much is that going to cost?
And you don't just walk in and say, I want to buy something.
No, you don't. No, I did not.
I mean, I don't want to call them cheap, but
Right.
I mean, let's face reality here. That it had to have an ROI, it had to have so this thing went through the rigors of that.
It did go through the rigors. It was a big to do because they were looked at as toys by many, right? Yeah, so instead of a fundamental foundational tool. So I did have to go through a pretty heavy process. It's not easy to convince those two guys.
I got pulled into it too, Jason, because I'm the chief technical officer. So
correct.
I think if not for your energy, though, and your passion for it,
sure.
I'm not sure. Everyone says, "Oh yeah, it's obvious. We got to do it." I mean,
right.
We had somebody who would champion it.
Sure.
Right, and stay up at night worrying about how do I make it work.
Correct. Lots of nights like that.
Yeah.
Lots of reading.
That's cool. So, Brian, your role is kind of beyond just the, let's start with the reality capture and lifecycle project, is the whole advanced design technology group, and this all kind of feeds under all of that. So well, first of all, for you, what's your definition of reality capture in your mind, and how it becomes a tool that really does advance where we got to go as far as moving forward in model-based and digital twin designs?
Yeah, as I alluded to in my introduction, I think the reality capture is just a foundational component that's necessary in the march toward a truly digital twin that our client may be able to use for a number of different things. So being able to quickly establish that data set that's going to drive that model or support that model is important to do so. Being that it's a foundational element, it is, however, going to carry through that full life cycle of the model-based design development and beyond. So it's important that we understand what the data is being used for, what needs to be captured, and plan that work accordingly to help build that groundwork.
And I know you at the beginning of your career, you were relying, like we all were, I'm older than you, but on record drives. You were getting a set of record drives. You went into a confined space chamber underground, and you're pulling tapes and dropping plumb bobs. And I think we got the dimensions right. We think we got the dimensions right, and you're kind of combating sewage and all kinds of other challenges, and rats and all that. And there's times when no, you don't. You don't have it right. It's off by 6 inches or 4 inches or 2/10 or whatever. So this kind of technology allows you to kind of go into any kind of confined space. But even for me, the going into like a complicated mechanical setting of a huge pump station pump room, and you literally can nail down every bolt if you wanted to, right?
Correct.
With this equipment that you can walk around with portable data. What'd you call it? Portable data collection?
Mobile mapping system. Yeah.
Mobile mapping system.
Sure.
Right? Remember, I had Fortran cards.
Yes. Makes sense.
But to me, to see that, you guys spend a day or 2 days, and to see, as if I'm kicking off a design or you're kicking off a pump station design, wow, you got all that data that quick.
Sure.
We're building on not just worrying about where the record drawings are right. This is reality.
Correct.
Thus, reality capture.
Yes.
Right. So that's kind of cool.
Yeah, I think if I can jump in,
You can jump in. You're the
Great.
You're the guest. I mean, come on.
Yeah.
an interesting story. I think you mentioned the mobile mapping system and how we use the data in a number of different ways, and I'm sure Jason's going to comment on that in more detail. But the genesis of that part of our offering was really driven by a project need or a project workflow that we needed to address conditions that you mentioned about confined space, taking tanks out of service that we wanted to get in and out of very quickly. We wanted to collect all that information, and this evolved probably 4 or 5 years ago.
Yes, 4 years.
The project requirement identified very stringent language about the condition assessment of this particular project needed to cover every square foot of every surface on the facility. So
Wait a minute, every square foot of every surface on the facility.
Big tables and chairs. And
Well, it was
a reservoir.
It was
Reservoir, okay.
intended primarily for structural
structural,
condition
okay.
assessment. So we needed to be able to address that requirement,
Yep.
and we needed to be able to do it efficiently, so that we could capture that information. So we developed a work plan that would allow our team to do that. So we could collect 100% coverage from a scanning perspective. And initially, we thought it was going to take the form of a number of our aerial technologies to do that, so we could get high areas on the ceilings and inaccessible areas. We found some challenges with that approach, so we were able to adapt. We spent significant time investing or evaluating a number of mobile solutions that would bolster our ability to do that.
So and a new technology like this, right? It's not the standard what you've spent your whole time doing, but you know it's going to give you something that could be amazing. What kind of hiccups? You said we learned and we kind of made some adjustments. What kind of hiccups did you learn as you're implementing some of this stuff?
Yeah, well,
You're talking about the mobile capture stuff in this case, not flying a drone around a pump room.
Well,
right?
well, it includes.
Did
both.
you fly a drone
It includes
around?
both.
Oh, you
And-
did.
Yahtzee.
and
I
that-
did.
And that created a number of challenges because these are large spaces, and there were many of them, and they're often underground or concrete tanks.
Underwater.
Perhaps.
We'll get to that. This story.
Yeah, but some of the challenges, as you suggest, are if you have drone that loses its signal to GPS or RTK or whatever signal it's using, that means the pilot has to fly
Yeah.
manually, right?
Yeah.
So there's some challenges in that environment. There are also some of the challenges that you can expect with the environment itself.
Wait a minute. The pilot. So when you're doing drone work, you can do it on autopilot without manually. So what percent of the time are you doing autopilot? What percent of the time are you doing? Oh, we got a problem here. I got to go.
Sure. Well, it all depends what the data is going to be used for. If I'm performing aerial mapping photogrammetry, right, or aerial LiDAR scanning, I design a mission.
build a grid and
I build a grid and the drone flies it. I rarely fly. If I'm flying for something like that, if the output is a 3D model or a terrestrial, a topographical survey, it's autopilot, right? We have drones that are very capable of doing that. So but you have to have knowledge. What's the data going to be used for? What size of deliverables do you need? Because when you talk about hiccups, there are limitations to that, right?
Size being the size of data.
Correct.
Billions of data points.
Sure. If as an AEC firm, when you're designing, you're limited to the size of the data you can use in design, right? The other softwares that you're going to use to import that data, they have size limits, right? So if it's a very large property, I may choose to fly that in 10 pieces, right? Or, Florida, for instance, I flew 11 miles, 12 miles of highway. I did it in bands, half-mile bands, right? Because if you get too big there, it's too much data and you can't really design from it. But, I mean, there are a lot of ways around that, but we want to be able to easily bring that data into our design software, right?
And you taught me in New York, you got to do a flight plan. And we were going to use drone technology, but, getting a flight plan and that tri-state,
Yeah, good luck.
A little bit difficult.
Yes.
The FAA. So.
Yeah, waivers. There's a huge waiver process for flights in the area we were looking at.
So there's reality capture, the concept. It sounds like you guys are actually getting into the different ways we collect all this data: air, land, sea. Can you walk us through? Yeah, what's in that toolkit? What's in your bag of toys that you're using to collect this information?
Sure. So from the air, we have a fleet of drones that are capable of really collecting anything from thermal imagery, LiDAR, photography, high-end photography, high-resolution photography. We have drones that are capable of flying in small indoor spaces. We've flown in tunnels before. And then from the land side, we have...
Wait a minute, how do you do like if you flew a drone around here and we got 6 people in here,
Sure.
it's like a bird flying around in the room. You'd be a little nervous, right?
Yeah, I wouldn't fly in here with us sitting here, but it's possible, right? The obstacle sensing on the drones we
Do you have
have.
limitations on space and that kind of thing?
Yes.
What kind of room you could go into, you know what I mean?
You can fly. I could fly this room. I mean, that's your limitations are certainly experience, right? Experience weighs heavy into having the level of comfort to fly in certain areas. I mean, we flew a job for one of our clients for a coating inspection up in the steel girders of the roof, right? So you have all the roof support steel, then you have all the angles, and Brian was right along there with me, and I'm flying a drone, navigating through all these steel angles. Not easy. And
if you crash it, nobody actually gets hurt, hopefully.
Well,
it's expensive
that's correct.
equipment.
It's very expensive equipment.
So you have to have confidence that you can do it.
Sure.
When you do it. And you're getting better at it as you do more of it.
Every day. You get better at it because it takes practice, right? You can't just
Don't
say,
ask
"Hey, I'm
Dave
on the
to
clock."
do it.
Yeah, I wouldn't
You're
ask
not
Dave to
asking
do
Dave
it.
to do it because you can't even get a mic on.
That's
Get
correct.
a mic on.
That's correct. Lose a limb or an ear. That's right. So we have every capability you can imagine to fly to gather all the aerial data. We can do it fast. Right?
What was what was the
capture.
toughest confined thing you had to fly? You talked about the girders on it. Was that?
That's the toughest.
That was the worst.
That was the hardest because I've flown inside other facilities where I'm flying over ductwork and I can't see the drone and I'm counting on just the camera.
You lost.
I lost visual.
You're literally going autopilot.
Correct. Manual pilot with using obstacle sensing.
Right.
In looking for a leak in a duct that was over a duct. Right. This was for one of our clients. Asked if we could do that.
So if you have a structural engineer with you, is somebody watching while you're doing it and actually taking the information down?
Correct. I will have him, Brian, or another engineer with me looking at performing their visual assessment of an area as I fly. We have a master and slave remote for that purpose, right? Or we'll hook to a big TV monitor so multiple people can watch, depending on what we're trying to accomplish.
So these are the variations of air. I mean, air could be actually in a room.
Sure.
But
it could be inside or outside.
More likely out in the atmosphere, you're above whatever it is you're trying to capture. And
sure.
You're flying a drone either on autopilot or manual.
Yep.
So when you go to land now, because this was the piece of equipment that you guys are talking about, you could literally have somebody wearing something on a backpack, right, or a person-mounted device,
correct,
and walk a very complex facility and capture all that data as you're walking around.
Yeah,
he will go anywhere that he can fit. So, and
I'm that guy. I go everywhere.
You got to make sure that you can fit in a lot of places.
Yeah,
so you got to watch the.
Yeah, so I gotta. Yeah, keep this looking good.
Put you on a training program. But
it's the Wade Trim lunch policy. So, so the mobile mapping system is really state of the art, right? And everything that the accoutrements that come with the software platforms that come with that data are astounding. I mean, it's a real wow when we go into these areas. And you mentioned going into a wet well, and I think I have everything. I think I measure everything. So it takes the think out of it because we did exactly that. We went into a confined space that was very difficult to enter, and it took a lot of resources to shut everything down to allow us to even access the area. So we made sure we had our ducks in a row. We scanned it multiple ways, right? We scanned it with traditional terrestrial scanner, tripod-mounted scanner, and I mobily scanned it as well. And the greatest part about that is you left nothing behind, and you can really shorten the duration and the hazard to the folks inside. Because if you can imagine, this was it was a wet well that was very deep, and it had these tunnels, these siphons that run up into pumps. To try to measure that with tapes and a pencil and paper.
Jason, how do you know you captured? I mean, so it's like mopping your floor, or whatever. You can see the wet,
Sure.
I got the whole floor.
Sure.
How do you know that you captured everything?
That's a great example because on the heads-up display, I see the point cloud being built. Right, so as I'm walking around,
the gaps being filled in.
Correct.
Wow.
Yep, it's color-based too, right? It starts out white. The area, it starts to read the area. The scanner's reading the area, and we have and it captures panoramic imagery too, right? So when I start the mapping operation, it's constantly mapping, 480,000 points per second.
Wow.
So as I'm walking, it always captures that information. And then, having the engineering background, I know what I need to photograph. So I will stop and take a manual photograph, and that single image is going to record everything within 30 meters. Is the focal accuracy of that image as you zoom in online, right? So you're capturing all of this data. So I'll do that every time I think, okay, there's some cracks here, right? There's delamination there. Here's a spall.
Yep.
And then, so not only am I capturing all of that photography, but you're also capturing the structure. And I can come in and I can process that data. I can now hand it over to the client who can now do their assessment, right? We've done our work. Here's what we think needs to, these items need to be reviewed.
Yeah.
Take a look at these repairs. And but now the owner has that data, and also there's so many different things you can do with it. I hand it over to Brian, and there it goes to advanced design technology.
Yeah. So this is the land, the land example. So you got a pack, and you want. There's also a cart for larger areas you can push around, right?
Yes.
So
same technology on wheels.
On wheels
instead of wearing it.
So which one do you prefer? Give me why you use one or the other if you're in a setting. So.
If a great example of why I would use one over the other is if you're in a parking garage, let's say. It's just a vast, wide open space, very few columns.
Yeah.
Right? I would use the cart.
Or a big clarifier.
Sure, something like that.
Easy to get around on.
Sure.
And roll it around. Right?
Over 150,000 square feet, right? I will, because it's taxing. You're wearing the wearable device is about 60 pounds. Most of the weight goes down to your waist. Correct. So that answers your question.
You're lugging 60 pounds around
too.
for 4 hours. I think you're getting a workout
Yes,
in. Yeah.
that's correct. And I prefer the wearable because we can go into areas.
So you do prefer walking with it?
I prefer walking with it.
And you can see while you're doing it. I've
Yes.
got it all covered. And
Right.
All right.
And we purchased the trolley early on, right? Early in our. For our proof of concept that was performed by the manufacturer, it was with the trolley.
Okay.
And then the wearable was not even available to the public yet. So we had an early glimpse at that, tested that out and said, yeah, because we're able to go into areas you'd never be able to get a scanner into. You can just crawl under things, which I do, right? I go anywhere I can go while I'm scanning, I get there.
So without naming a project per se or whatever, what was the toughest assignment you had either by air or land to gather that data? I know you talked about the girders, but
Sure.
Is that it, or is there another case where you could?
That was tough because you're not holding something, right? When you're talking about drones, aerial drones, there's no way to grab it, right? If something goes wrong, I would say that's.
To grab it from.
Yeah,
I mean,
I do. I would say that was the toughest, though. That was
got blades going.
Yes, everywhere. That was certainly the toughest. I mean, we've been in some pretty challenging environments, wearing the mobile scanner. But you get there, you take your time, you know where you're going to. I mean, you know what you're getting yourself into. I always know. We walk through areas first and say, yes, I'm capturing all this. I might not be able to get that over there, though, right? So
we've got the trolley, we've got the pack, but you can also put these on vehicles, right?
Sure.
You can drive it around and.
Yes, in Wade Trim, we do all of that, right? So we have mobile scanners, we have terrestrial scanners, we have vehicle-mounted scanners, we have aerial LiDAR scanners.
You get a whole
right?
freeway, like just
Yes.
drive along and.
So it's just having all these tools. We have the tools, and people reach out to us, project managers or clients alike, or contractors, and say, "Hey, I am looking to have something like this done. Can you do that?" Sure, we can do it.
So Jason, with 480-some thousand points, what 5 minutes or whatever it took you to do, I don't know, with a linker rod, a plumb bob, and a tape.
Forget it.
Back in 1983.
Yeah.
When I'm doing this thing in the summer.
Sure.
How long would it take me to do that?
If you wanted to gather every point, if you wanted to gather a survey XYZ for every point that a drone captures,
it's not just I got this point, I got that point on the other end. I'm gonna solve for the difference in the elevation. Say it's a common.
Sure.
We did this with topographic survey all the time. We're making extrapolations.
Yeah.
Right?
Yeah.
5-foot intervals or 10-foot intervals or depending on the job, 50-foot intervals. You're doing it literally, all of it.
Yes.
I can tell you the difference between this point and the one 3 inches from it.
Sure.
See, that's amazing that this has evolved to this point.
Well, and that's if you zoom into a point cloud, for instance, and try to figure out what it would take to do with traditional survey with a rod, linker rod, you're getting a point every inch.
You
right?
know what a linker rod is, at least.
Oh,
At
yeah.
least you know that.
My dad was a surveyor, just like
I
yours.
don't feel that old.
Yeah.
I mean, it's,
I used one. Good Lord.
you had to
But,
put your thumb on there and move
yeah.
the tape.
Oh,
and
yeah.
it's-
Lock it.
You're kidding, and then they're yelling at you because the hand signals aren't working.
Yeah.
And it's just awful.
Boy, have times changed.
All right, so we've covered air and we've covered land. Now we're going to talk about sea, and I'm going to have a little quick story. Before I became a consultant at Wade Trim, I was actually an officer in the Navy with the Civil Engineer Corps. And I was a public works director at a little base called NSC Cheatham Annex in Williamsburg, Virginia. And we had two of the longest piers off the York River in the Navy landside, servicing, I think it's classified, I can't tell you what it was servicing, but we had these super long piers, and they had to be inspected very frequently because of the urgency and the national security importance of these things. And we used to survey every bolt on every pier using divers.
Like Navy SEALs, or what do you?
I don't think they were Navy SEALs, but professional divers. Okay. Don't get too dramatic. But they would go in there, and some of them were so murky they'd have to fit. And I think that would be a challenge underwater too. But some of these conditions with divers get pretty dangerous.
Sure.
Right. Now this one, my experience is not as bad. There's another experience we had, and you guys might remember, in Detroit almost 25 years ago, where a diver actually lost their lives inspecting an underwater sluice gate. It can be dangerous work. So the ability to be able to do it with a remote device that can swim, you're going to tell me the details, and capture this information, not just capture it instead of a person, but capture with a lot more data points, as we've been talking about with air and land, than a diver could possibly identify and capture, right?
Sure.
Maybe there's no replacing touching something if you can do that. But so tell us about this deep trekker, which is, or any of these devices that go subterranean or
Nautical
subaqueous.
drone.
I guess it's
Sure.
subaqueous.
Nautical drone.
Yeah, subaqueous.
Subaqueous.
Yeah, there you
There's
go.
the
So
word for today is subaqueous.
sure. So we talk about tools in our toolbox. We have a Harbor Scout nautical vessel, which we primarily use for bathymetry, right? So we're going to scan the bottom of a pond, or the bottom of a lake, or a channel, or a river, and we're going to build a point cloud out of that data. And then you can put that together with aerial data, and now you can see. I mean, you have from the treetops to the logs laying in the bottom of a channel. But the deep trekker is unique in that it can also perform bathymetry because it has utilizes onboard live sonar, but it also utilizes a couple tools. We have different tools we can place. So to give you details, it's small enough to fit into a manhole, a standard manhole opening, right? 28 inches, 24 inches. It's small enough to fit down into an opening like that, but yet it can travel 1,000 feet, and it's steady for 1,000 feet down, 1,000 feet out.
So you can do 1,000 feet vertical, 1,000 feet horizontal.
From where you're sitting.
At that depth? You can?
Correct.
Okay. Wow.
Well, it's on a tether, right? So that's when we talked about the what makes you nervous when you're flying up in ceilings. This is on a tether. Worst comes to worst, I can pull it back, right? So we have had a battery failure in the past. So you talk about hiccups. Well, we have long battery life, but you just want to see that one more thing.
And it always fails when you need that one more thing.
Correct, that one more thing. So it's only happened to us once. We were able to just pull it back, reel it in. But we have utilized the pivot, and that's the actual model. And they call it that because it can pivot, it can side scan, right? So when you're talking about inspecting a pier, for instance, and we've done a lot of this on dams, right? We do a lot of dam inspection, stop logs, or any type of valve work, piping underwater. We worked with a client to look at their water intake and the scale that's developing. And this, when you talk about dangerous for a person, they wanted to get an idea of how much scale is on the screen, the intake, right? Then they have this air blast bubbler system that will actually blow from the inside of the screen and clear it. Wow. So I was able to take and they wanted to see what that effect was immediately.
Yeah.
To do that with a diver is
Well, it's dangerous.
Yeah, it's dangerous. I mean, it's 20 feet deep, and you would almost have to be tethered off to something. Well, I was able to take the sub right there.
Wow.
And we did an inspection, and we were able to see the flocculant system that drops down to the screen, right? So you have this flocculant coming in. We're able to actually just side scan this and watch all the little flocculent feed ports drop flocculent in, and then stayed there for the big boom and
Jason,
safely.
you talked about how to know that you're done if you're doing an aerial device survey and
Sure.
by land. You can tell when you're done.
Yes.
When you're underwater, I mean, first of all, being underwater, why would you even do it? Is because you can keep a system in service
Sure.
and actually inspect it without taking it offline, right?
Correct.
I mean, that's a huge benefit. But how do you know you're done underwater with data?
Well,
You're not going down there with a
pre-planning.
snorkel and say, I
Correct.
got it all. I got
Yeah.
it all. Right? I mean, so you're.
Yeah, typically we work off plans, right? And
Okay.
say, okay, here, but this is all part of the toolbox talk pre-planning, right? We do this with drones, the JHA, right? We're going to go through everything we're going to scan. When we're going to scan something wearing a mobile device, we're going to walk it first. When we're going to fly something, I'm going to check the FAA website. I'm going to check. We use a lot of tools for that.
Tell
I'm
me
going to
you're
check the
swimming.
wind.
Don't tell me you're going to swim. when you're going
No,
under.
do a
don't-
cannonball and swim down. It's the only way to enter the water professionally. So we'll pre-plan everything out, right? So we knew what their goal was. That's how you know you're done. I mean, I think you're going to know.
Is
when
it a
you're- when
little
you're
less
done.
assured when you're underwater than it would be if you drained the whole thing and walked it with one of the land devices? Or
No, only because we know our location, right? We have GPS readout on the screen. Much like a drone, you always see where your drone is.
Okay.
Right? When you're flying, when you're mapping an operation, you should see your drone because that is a requirement under Part 107, right? But you also can see where your drone is on a map. Same thing with our submersible drone.
Yep.
But we've used it for that case. We've inspected seawalls with it. We've inspected dams, like I had mentioned. We've done that frequently. We've inspected tanks, right? Tank lines, and that actually could lead into a pretty funny story.
Yeah, I wanted to make sure he didn't forget or allow you guys to move on.
Is he a funny guy?
He's pretty funny.
Fun
If you
guy.
wait a minute, fun guy. He's a mushroom.
Yeah.
I don't even think you've smiled yet today. Okay, so you're going to say something funny, Brian.
Yes. Well, I don't know that it's funny, but I wanted to point out. Well, you can tell the funny story after this
Yeah.
if you'd like. But I wanted to point out that as we've gone through all these technologies, they do work and stand alone. But we've found opportunity to combine them in a number of different ways to meet a particular need for our client or offer a particular solution. I can let you comment on, but there was one particular space that we wanted to get underwater information and above water information
In a closed
in an enclosed
System, okay.
system. So there's some challenges there because you've got
right.
one wants to look down, the
one's
other one
doing
wants to fly.
bathymetry, the
right?
other one's kind of looking.
So you can comment on the approach, but we basically integrated two to get what we
But
needed.
quickly, because Brian's background, as we all know, is a structural engineer. But so if you're getting underwater data from one of these devices, and you're looking at it structurally, I'm looking for cracks, looking for deformations, looking for spall, whatever it is. Are you getting the same kind of information you would want if it was empty, or are you sacrificing something there being underwater?
Well, I think you don't get the hands-on experience.
You can't touch it and hit it with a hammer and all
Right,
that.
but in this particular example, it was an initial study. So we wanted to get eyes on it before the tank was eventually taken out of service, which might be a year down the road.
Right,
But we wanted to have a preliminary understanding of what we're getting ourselves into.
So you felt comfortable with the results that you got looking at?
And we worked closely with Jason to develop the plan. So we had our structural engineers looking over his shoulders at the secondary device, and it worked out fairly well. But if you
think it worked out
if you could just comment on the two technologies.
So in the spirit of time, what's the funny story? Because that wasn't that funny.
Well, it's, the funny story is we tested what camera will work at that great distance, right?
Okay.
So the boat has long range telemetry. So we're talking about our nautical vessel.
So you're testing the boat.
Well, no, we're not testing the boat because we know how the boat works. It doesn't have a camera on it. The boat uses sonar, right? And side scan sonar. So it uses two different types of sonars. So we're testing what camera is going to work when we drop it through an opening down 8 feet and then go out 400 feet. Nothing works. Nothing works. We tried Bluetooth this. We used the Apple. We used all these different kinds of technologies. And then they thought, well, a drone will work. So we actually took a $30,000 drone and mounted it to the boat because...
You had a drone in a boat?
Yeah, we had a drone mounted on top of the boat.
It's like a plane going to Europe on a steamship.
aircraft carrier.
Yeah.
It worked
Aircraft carrier.
perfectly.
Right.
I had tested
So this is your
thing in
aircraft
tunnels.
carrier inspection?
Correct. Because
Tiny aircraft.
because of the type of so Bluetooth technology, everybody knows that. Their phones have it. It's not very effective through walls, through doors, right? Everybody's been wearing an earbud, go out into the garage when their phone's in the house, now you can't hear what you were listening to, right? So drones utilize Q-Link technology, and that's why I can fly a drone 3 miles away from where I'm standing. So we mounted the drone to the boat. I controlled the boat with the boat remote, right? Watching what the drone sees, because normally I'm scanning out here with the boat, I can see it. It's an open water vessel, right? So I'm actually watching the first person perspective camera on the drone that's mounted to the boat, and I'm driving the boat with the boat remote while the engineers are using the slave remote and looking at the data on the camera. And they can move the camera that's mounted on the drone that's mounted on the boat.
And you're
they
not,
can move
you're
that
not
all around.
you're not on skis behind
Nope.
it doing that.
No, we asked the squirrel. No, but that was a way to marry technology. When the client says, "Can you?" We sit down and we get our heads together and say, "We probably can."
Jason, before I lose the thought, and I lose thoughts lately because I'm 60 years old.
I'm with you.
The limitations of being underwater. Now, I'm more sewer than water in my history, right? So there was recently a project where we were trying to do an inspection of a surcharge system under sewage in a deep, big pipe. And one thought is, can you get a deep, or one of these types of devices to actually take data in a turbid, sewage-based environment, or even a primary clarifier at a wastewater plant. I mean, are there limitations to what that thing can do underwater if you're in a sewage-filled turbidity base? So you want to be in a clear kind of raw water.
Gray water is fine.
Gray water. Okay.
Again, it all depends on what your ultimate goal is. If you wanted to build, a surface, you said, "I want to know how deep this channel is and what's in it."
Yeah.
You can do that without any type of visual, right? You can use sonar to do that.
Yeah, right.
You can use underwater LiDAR to do that, to complete that work, because it doesn't necessarily... Now, if you have processes running, as we've determined...
that treatment plant, right?
Correct,
That
it's a
grid
problem.
channel,
It's a problem because when you have all this grit
bubbles,
and air bubbles blowing all over...
It creates
Correct. So in sonar, it doesn't work. Now, if you have the ability to kill the processes, right? Let's stop the air, let's stop the flow. We got excellent data out of that. But right now, we're always looking for solutions. I mean, we're thinkers. We try to stay ahead of the game. So a solution would be something that would work in that situation. So I actually talked to vendors in the U.S. and Canada, and we, they say, "Well, what are you looking for? Is there a device we can build?" And so I've had you talk to a couple of my guys, and Dave Delia too, and we're always thinking of solutions there, always trying to stay ahead of the game and think of a workable solution that is going to impact the client the least, right?
Yeah.
I don't want to shut down my water. I don't want to shut down my bubbles. Well, unfortunately, right now you have to.
You have to make a call. All right, so you've been a great guest so far, telling all this stuff. You've done a great job.
Thanks.
We got to feature Brian a little bit. I mean, so now all the reality capture, air, land, sea data, billions and I sound like Carl Sagan. Is it Carl Sagan? Dr. Sagan? Billions and billions of data. Now it's going to the design, next step in the design life, which is, okay, let's build Revit, and let's build a Revit model of the existing condition, if that's the case, that we need to do it for rehabbing something or whatever, or build it an environment where we're going to place a model within it with a new design. So what is, the handoff, Brian? How does that work, and where do you go with it? I know you've answered a little bit already, but what's your lessons learned, and what would you, say as you've evolved on this, innovation? What, how we've tackled it today versus 5 years ago versus 3 years ago or whatever.
Sure.
When he was doing cannonballs and a clarifier.
Sure. I think one of the challenges, from my perspective, historically, has been understanding what to do with this data. So even 10 years ago or so, many people, including our own folks from a survey perspective, were routinely gathering the information. So they were doing the scan data, they were providing it to the engineering teams, and then the engineering folks kind of scratch their head and say, well, what do we do with this, right? So there's an interim step to be able to use the data in either case, whether it's that terrestrial scan data or the mobile scan data. there may be an interim step that somebody
Like
needs
clean,
to process and
polish
scrub
it,
the data,
right.
and if there are birds flying around or cars in the way that you may not want or need. It's just noise that can be processed
And
out.
you know how to filter that out. You can tell with the
Our team does. They work closely with Jason or somebody that provides the data to be able to process it and get it ready for the model-based
How long does
design.
that process take? I mean, obviously varies on the job size, right?
Sure.
But I mean, it's not something you can do in an afternoon per se, right? I mean, it takes a little bit of.
Probably not. I mean, the kind of the basic core processing could be done in an afternoon, I would think,
Okay.
or a
All
day. What's important, I think, to understand is what are the next steps. So, are we gonna take an algorithmic type tool that's going to take that data and try to streamline the scan to BIM process, or is the data?
So what? So you got an algorithmic tool that can do that?
There are several.
Have you? Okay, well, explain that a little bit.
Well, what it does in simple forms is this software, say, for example, recognizes that a cluster of points that are in a cylinder shape.
It can tell what Jason did wrong with the reality.
Precisely.
Yeah, that in that scenario, it's likely a pipe.
Okay.
So it can streamline the BIM side of it because it's now populating that
So
model.
it takes all this data algorithmically, filters it out to show. All right.
Yep. So there's still some challenges with that, and there's still modeling that needs to take place from the BIM team. But the data can be also used in the BIM environment where if it's an existing facility or existing data set, we can use that information to either build the model around the data, or we can use the data to validate, say, a model that was developed from historic plans or something like that. So the data can be used to support the modeling in a number of different ways, and it could go either way.
And Brian, you guys have used that term BIM a couple times now. Like for folks that maybe aren't as familiar with what BIM is, could you give us a bit of an overview on that?
Sure, and I think I'll start with BIM and then just comment on the digital twin. I know it's not exactly the topic of today, but they're related.
But they feed each other.
They feed each other and they're related. So BIM is building information modeling. Many people think it's a software. It's really not. It's a workflow. It's a way of delivering model-based design to our clients. Right. It has intelligence associated with it. So if we built this room, the wall will know that it's a wall, and it has certain composite properties, thermal properties. So it's really building that intelligent model that can be used either through planning and design, into construction, and well beyond.
Like to maintain the building and operations and CIP planning.
Yeah, so we're seeing a number of clients that are forward-looking, and they're thinking about, how do we take this model now that we've invested in? How do we make it better? How do we integrate it with other solutions that we envision? For example, asset management or maintenance programs. How do they?
The life of a project all the way through its
and so that's
service
I guess
life.
The living
project,
yeah.
as Dave says.
Yeah, and that's kind of where it ends. That storyline is with the digital twin, and digital twin means different things to different people, and I don't know that there is a right answer, but the general approach, the way we look at it, and how we're kind of envisioning how our everything from reality capture, advanced design, technology support is the digital twin is where we need to end up, or our clients need to end up. So it's using big data. It's using a number of the TAPs that you guys discussed.
Technology action plans.
Technology
right?
action
His job
plans.
is
So
to define the
So
acronyms for you.
a number of those initiatives.
You can smile.
A number of those initiatives support this from a number of different directions.
Yeah.
But the digital twin, in its simplest form, is we have a model that's intelligent now. Eventually, there's going to be the real twin, right?
Right.
So the live building.
How far do you think that's away? When I went to this technical leadership conference in New York, they were talking about that not being that far out, where you're actually building structures through a digital twin environment.
Into the metaverse.
Well, not virtual, real. I mean, they're actually building it with a model that actually builds a physical full-scale model of what it is you're trying to build.
Correct. Yeah, and that's occurring now in certain industries.
I know it is. So how long do you think that's before that becomes a norm?
I think
me,
it's,
right?
It's 5 or 10 years. I think
it might
it's
not
probably
be after me.
reasonable.
Yeah. All right.
And that means delivering the model to whoever the next user is, if it's a construction
So you see it
contractor,
that quickly evolving. That's pretty amazing.
It likely will in certain industry or markets.
All right, so Brian, you're not as old as me, but you got a few years. You got a few decades behind you, right?
Yes.
So when you came into this industry, we weren't talking BIM, we weren't talking anything like what we're doing now, and that's the same for you and even him. Even when he was playing in the band at U of M.
Yeah.
You look at the kids coming on board now, and this is my observation. Maybe I'm way off, but you tell me because you're the kind of the point person and overseeing this. They're able to adapt and pick up this technology very fast, very fast. So, what's your observation on how technology with the younger generation of engineers that are evolving seem to adapt to this pretty quick, and they will be pushing the innovation similar to how we pushed innovation for CAD and hydraulic modeling and all of that back in the day, right? So, what's your observation of that? Or am I wrong?
No, I think
that's what I see. I describe a structure to somebody or write it, and I've got this young engineer who turns it around, in minutes. Here, put it in your presentation today. This is what it looks like. So you tell me what your views are on this.
Yeah, I think you're right on. We have seen over the last several years that the younger generation is adapting to it very quickly. In fact, I had a discussion just last week with one of our senior BIM designers who has been working with a number of our summer interns. So we've challenged them to provide some support to some big modeling efforts that we have upcoming. But we've had the senior person working with several of the young ones in a kind of teaming approach to training. And he commented that he was blown away how fast the interns.
And they're becoming the trainers of the interns behind them, and it's going to be just going to be adaptive management. That's what we do because that's how they do their work. So I think I was right.
You're always right.
I was right. No, I'm not always right.
You nailed it, though.
I'm the chief technical officer. I'm right most of the time, right? No,
Exactly. Yeah.
So that's really cool. I think that's cool. I want to turn it over to David to ask a few questions, for his drop mic moment.
Oh, yeah.
When I say drop mic, I don't mean like literally drop the mic 5 times while we're trying to do this podcast. It's about making a poignant point and nailing it.
Sure.
Because this guy literally probably, and I don't know when the last time I had a project of significant size that I wasn't using what I would call model-based design, whatever, right? Going back to the early 2010s. He probably uses it as much or more than anyone we have at Wade Trim with the multidiscipline projects that Dave's working on. So what is your, view in all this as far as how it's evolved, how you use it on a job today, how you see using it on a job 5, 10, 15 years from now?
Yeah, I mean, to me, it's just been an incredible explosion of the technologies and the information and the way you're able to sit down and explain it to your project team, your client, contractors that want to bid jobs, and to have a team that can actually go in, rapidly collect. So I think of like the middle of COVID, right? Everyone was concerned about safety, didn't want to have in-person meetings. The idea of going to a project site and let's all meet and do a walkthrough, that all was shut down.
Yeah.
Right.
And so to have a technology where you can literally send a team in, capture in real time what the project looks like, what are those conditions, be able to upload that into a cloud, right? And then sit down anywhere and get on a Teams call or a virtual call and just go to that place virtually. Walk through it. Yeah, go into that model, be in that space. Everybody knows exactly what you're talking about, being able to zoom in on that doorknob or that crack on the wall. Measure the crack on the wall. You could see its condition. You could come back a year later and see if it got worse. But having all that information literally at your fingertips and being able to drive it like a little video game around was just a huge help.
So you're literally doing remote virtual field visits as you're designing
needed,
the project.
on demand. Right. You know,
That was good.
That was good.
Yeah, yeah. I mean, and we did that with bidders, right?
Yeah.
You know, we couldn't bring the bidders out to do walkthroughs on some projects, and now we use it all the time. We
Sure.
do a virtual walkthrough for them.
It's kind of second nature now,
yeah,
right?
and make it available to them so they can use that in preparing their bids.
Yeah.
So
Yeah.
to me, it's just been exciting to see that and to explain it to the public. I think that's the other end, is being able to do that with a city council, a board, and in a few minutes, show them this underground tunnel that's usually underwater, right? That no one can go in, and it's scary, and there's rats, and walk them through and explain it to them, and they get it, and it's just been great. So to me, when I think about the information, though, I also think about the engineering side of that and the accuracy of the data, right?
Sure.
We've had some of those conversations too, because you're bringing in so much data. You know, how accurate is it? How much can you rely on it? So I know that's always something that we're always thinking about in the background, but I don't know if one of you guys wants to comment on the accuracy of that data and how we use that.
So accuracy varies greatly from equipment to equipment, from technology to technology. You can always increase your accuracy, right? Certain applications don't require, quarter-inch accuracy. So, what you give and what you take, you give up speed, right? If you want, say, listen, I need millimeter accuracy here. Well, you're using ground control every, 30 feet, every 60 feet. Tunnel alignments, you'd have to put it on the floor and the wall, every 30 feet, every 60 feet. So we achieve great accuracy. Again, terrestrial scanners, high accuracy. Like everybody knows that. They've been around for quite some time. The mobile side can get that accurate. Drones are very accurate because what you're doing is the drone is collecting data. You're using ground control, visual ground control.
So you're still connected to those
you're
accurate
tying into it,
systems,
yes.
and you're tying into it.
Tying everything in, and it brings your model down and twists it, puts it right where it's, achieves perfect global location, right? Geolocation. So accuracy is always a challenge, considering these environments are challenging that we're in, right? So to drop a couple ground control points down into a lower wet well, 100 feet beneath the surface with wet floors and wet walls, challenging, doable, right? So accuracy will always, it helps to know the accuracy you're looking for. What do you require?
What do you need?
As a designer, as an engineer, architect, what are you looking for? What are you going to do with the data?
Yeah.
So the first question I ask when Brian gets a hold of me, when any of our clients or internal staff give me a shout, what do you need the data for? What are you going to do with it? Do you just want an aerial image? Do you want a large orthomosaic map, right? Do you want scanning in the ceiling area? If I'm in a pipe gallery, let's say. So it's going to depend. What you're going to do with the data is going to drive how I'm going to collect it.
So you can get to whatever level accuracy is needed by the application. The importance is to say, what level of accuracy do you need for this application?
Absolutely, 100%.
So I don't need millimeter accuracy on a topographic survey in areas I'm not even digging in.
Correct.
Right.
Yep.
I mean, you need it where you need it, and you don't need it where you don't need it. So you have to scale that to
you scale it.
give an efficient model. What you said was really poignant in the sense that I think it's becoming, at least in my experience, an expectation in the client's world that I'm not looking at plans and sections anymore as much as show me the model and show me how you made an adjustment. Let's get inside of it if we have to, and I'll give you my comments based on what I'm looking at imagery-wise, right? So whatever it might, it could be a junction chamber, it could be a pump station, it could be whatever it is. The clients are getting used to looking at, I used to call it way back when, the Discovery Channel, paradigm that changed our industry, that they could take a catastrophic, Engineering Disasters is one of the shows we all watch and hope we never get on, right? But you see them recreate something digitally, and it's Hollywood-based, right?
Sure.
You start to get to the point, well, I don't want you to describe to me what happened. I want you to show it to me, right? So if we're using like transient models in tunnels, for example, and we have the ability to predict geyser effect when it happens, I think where we're going is give me the digital twin of the actual tunnel system, load it with that particular storm hitting that area, and show me what the geyser looks like.
Yes.
Not just describe it could happen. Show me in your simulation what did it look like and what was the damage from that. And that gets back to your living in the virtual game engine world of, but you can't do any of that without reality capture feeding model-based design, feeding the other inputs to it.
Correct.
And that's where we're going in this. And my career started with Fortran punch cards. I mean, what do you, don't laugh too much.
I had a Commodore
I
64.
had a
Come
Fortran
on.
class. Yeah.
So anyway, this has been a great topic, and in the spirit of time, I think you've covered almost everything that we'd want to talk about. And we saw illustrations as you were talking about kind of how this cool stuff.
Sure.
And what it looks like and how it's used. But I'm going to start bringing it to a close here today. So let's start with you, Jason. Any final thoughts?
I don't think so. I think everybody has to, when you think about where reality capture is now, which I think Dave and Brian and I have brought up many good use cases, right? If you have an open mind, there are a million different ways to use the data. Training, right? Like you said, bidding process, right? Carrying data into BIM software and designing from it or with it. But the way this data is hosted, it changes. Like this technology, when we started looking at it, this technology was doing this, right? And now it's just, you have a lot of kickstarts out there. I love collecting data. I'm a super nerd. Anybody that works here will tell you I'm a huge dork, right? So I think...
I wouldn't say that on a podcast. I mean,
I would.
you don't have to say you're
Anybody
a
who
dork.
knows me and watches it, like, yeah, that's the guy.
Yeah, he is kind of a dork. No,
We've immersed ourselves in it, and Brian and I spent a lot of time researching. What are we going to buy? How do we get approval for all this? Hey, Ralph.
Well, and again, I
what's
get
that
back to
gonna
your
cost?
energy. If it
Yeah.
wasn't your energy and your
Sure.
drive that we knew we had a champion who would actually develop this and
Yes.
move it, you don't get that kind of authorization with that kind of investment if
Right.
you don't have a champion. So
Sure.
you are the champion.
Yeah.
All right, so in the spirit of time, we're going to move on to my Michigan State cohort here.
Go Green.
Brian,
All
go
right.
Green.
Something that came to mind as
Did you wear the glasses to look smarter today? Is that the...
so I could see. One item that came to mind as he was wrapping up and you were segueing to him, the future of the digital twin. There's an umbilical cord there between the built world and the digital twin.
Yeah, right.
And that information ultimately, I believe, is going to be feeding back and forth. So that predictive analysis that you're thinking of, from a sewer perspective, you could picture that in any application. So in that case, if there are remote sensors out there that are collecting information on pressure,
You could feed it
water
back into the
conditions,
digital
you could feed
twin.
it back.
Yeah.
And you can generate predictive modeling for whatever it is,
Yeah,
right?
yeah.
Same with the building. If there's feedback on thermal issues, heating and cooling, you name it, right? So you can imagine that the data or the information is going to be feeding back to the digital twin, and those are going to work together.
It's going to blow us away when it gets to the level it's going to go. So, Dave, why don't you get some closing thoughts, and then I'll bring it home.
Yeah, it's just exciting to me. I love that reference of the umbilical cord and how things are all connected and tied together, and it goes beyond just projects. Projects. This building is in a golf course, which is next to a road, which is in a city, which is in the world, and this whole smart city and the idea of everything being interconnected and capturing that, tracking it. What do you do with all that information? How accurate can you get? Where is it coming from? It's really exciting to see, like you said, that roller coaster of possibilities that are out there. And I'm just glad to get a chance to work with you guys on our projects every day and continue to fight those challenges.
Yeah, it is fantastic. So I'm going to close told some stories today about just how far engineering in general has come in my limited career over some 40 years or whatever, and really blown away. I could have never imagined back in the day, right, that this is where it would evolve to. And then I'm thinking to myself now, where the heck is it going to be 20 years from now, 30 years from now, right? And I think the closing thought I've got now with this whole advancement is, if you can imagine it, it's going to happen. And like the whole thing I told you about the imagine, you could simulate a geyser in a tunnel with a game engine. We probably could have imagined that 10 years ago, but never thought it would happen. I think now, whatever you can imagine is going to happen for the most part in engineering from this field, this reality capture, digital twin, model-based design evolution that's happened in a relatively quick time period. I mean, we're talking
Very fast.
Brian, 10 years.
Yeah.
Years, yeah.
10 years since it went from a thought to reality. No pun intended, but it is a reality capture podcast, right?
Sure.
So with that, I'm going to bring a close to it. I want to thank everyone for listening in. This was really fun. You guys were great guests, and more to follow. We have our third podcast coming up next month, and we have an exciting topic that I'm going to kind of hold off on before we announce
like it.
So, all right. Well, thank you, everybody, and have a great day.
Thank you.
All right.
Gentlemen.